This is Rick Harnish, and I am the Executive Director of the High Speed Rail Alliance. We are a member-supported nonprofit advocating for fast, frequent, dependable trains connecting the whole country. We believe that there need to be a mix in a very highly integrated network of new high-speed lines, with a vast majority of those designed for going faster than 200 miles an hour, linked into a lot of upgraded mixed-use lines, and connected well with expanded and improved transit. And if we can do these things, we'll reduce our cost of living, we'll make life a lot safer, and we'll make our communities stronger and more economically resilient. So this is the second of our video brown bag lunches. We've got a couple of more scheduled for September, and a couple of more on the bubble that I think will be very interesting that we'll have in September. Our current issues that we're watching there's three at the federal level. The first is an emergency appropriation for COVID relief. So it's called a lot of things in the House: the HEROES Act, COVID relief, the stimulus bill. Currently, the Senate and the House are deadlocked on that, and so we're not sure if that's going to move. The House version had transit funding in it, and the Senate version didn't. And of course, we would prefer the transit funding be included. The next is the 2021 appropriation, and 21 starts on October 1st. The House has passed a version of that bill that would include $10 billion for Amtrak and other intercity needs, and substantial funding for transit as well. Not sure how that process moves forward, but it's exciting that there are folks in Congress willing to put that much investment into our national network. And then the third is the overall authorization, which is a multi-year definition of the program and defines spending limits. And again, the House has passed a version of that we really like, but that process will be ongoing. The deadline for that is also September 30th, but it's likely to get pushed back as time moves on. So we'll have more on that in future webcasts as things develop. But today, we've got Miodrag Vidakovic, and he is, I'm sorry, under pressure, I forgot where you're at. I'll let you do your introductions of where you are, Mio, but he's put together a new proposal for how to monitor pantograph interaction with the wire, and we're very interested in hearing about that today. So go ahead and take it, Mio, and you should be able to share your screen.
Thank you very much, Rick, first of all, for opportunity to be here today and to be able to present what I have been involved in. But before I start, I would like to just give a brief introduction about myself. I've been at City University of London for about 8 years, where I completed my master's degree and my PhD degree. And my PhD was mainly involved in developing a system to monitor railway pantographs. And during that period of time, I brought the product from approximately TRL 2.3 to TRL 7, where it ended up being tested in the real operational environment. And I also do share the same vision as a High Speed Rail Alliance, and I'm glad that we met a couple months ago, and I'm sure we will try to find a way to work together in the future to bring more electrified systems and integrated systems to the reality. Today, I would like to tell you a little bit more about my vision and about Internet of Intelligent Railway Pantographs and what I mean by that. So, pantographs to date have been mainly passive, which means they haven't been really monitored, especially in a regular service. And as a result of them being passive and not knowing what's actually happening, we in the UK experience about 90 plus pantograph incidents per year. All these incidents do have financial implications of about £2 to £3 million per incident itself. And this is without considering how much the tickets, refunds, stopping in services, penalties, and etc. This puts infrastructure, the downtime, and does introduce the cost towards regulatory bodies as well. On top of that, you have millions of unhappy passengers. And some of these scenes on the right-hand side, they actually happened quite recently. One of them was just before the lockdown at near London Euston, one of the biggest stations in London. And during the lockdown, I had a bit of more free time, so I wandered around the stations around my area. And one day I pop on train to go to get my medicine. And I saw the message in the station says, drivers do not forget to drop the pantograph, which was a bit of a shocking to me, to be honest, because drivers do have quite a lot of responsibility. On top of that, they need to think to drop the pantograph. So you can imagine if they don't drop it, what would happen soon after they leave the station. So this is the main motivation for what I was doing during the PhD, and is development of a system that can be used in real time and not only on the commissioning and measurement trains. It can do both, but the main focus is to be used in real-time passenger trains. The system itself is fully based on fiber optics, which means you don't have to worry about 25 kilovolts interference, etc. It's very lightweight and a small size. You can imagine fiber being as thick as a human's hair. And the sensor length is typically between 1 and 8 millimeters long. Just to show you basic principle how it works, I'm not going to bother you with the theory. So you can imagine that being as a mirror in the fiber. When you launch some light, then you have a reflection from that mirror. And that reflection tells you how much of force, how much of temperature, how much of acceleration is actually applied to the railway pantograph. And this is the principle we use. Why do we actually do it? Who are the people who need it? So I divided this into two main market segments. The first one is infrastructure managers, who are separate entities from train operating companies in the UK. They have a couple of challenges. First one is every time new infrastructure is installed, there is important TSI compliance reports that needs to be delivered to say that there is efficient current collection while train is operating. On top of that, they also need to check the quality of the infrastructure that has been promised by the builders. So these are the two reasons, and these are the situations where they would need to hire trains to do that. On top of that, I'm just talking about UK figure. There's about £500 million cost involved with the maintenance of pantograph overhead line related specifically. In addition to that, regulatory bodies are putting significant pressure on the infrastructure managers to maintain the network, to deliver certain reports. And obviously they also want happy passengers. And on top of that, these infrastructures can age over time. And as a result of that, you would need to monitor those infrastructures and know what the status is. On the other hand, if you look at the train operating companies, they have no idea what the pantographs are doing while they're in the field, when they're going to cause the incident. And at the moment, they can't prevent it, nor predict it. Cost per incident, as I mentioned, they are significant. And on top of that, I didn't calculate into that how much they spend on ticket refunds, stopping their services for weeks, and etc. On top of that, there is a document which is called National Rail Passenger Survey, and if they get criticized, of course, they don't want to see their passengers being unhappy, so they need to do something. As a long-term goal, and I believe when we do have significant amount of data, we could help these companies reduce their electricity bill through more optimized current collection. And this is something that we would like to do as well in the future. What does it do? What can system actually measure? So you can see that there is two parts of the system. There is obviously the edge and the cloud. On the edge side, you have a camera, which provides a visual feedback on the pantograph operation. You have sensor data feed, and what sensor data feed means is, I'll tell you in the next slide what it can measure at the moment. and why is it important. And then you have a GPS feed, and all these three are synchronized and put together. And then it really depends what the user wants in the end. Do they want contact force, mean forces plus minus standard deviations, or they want to see where the problems on the network are, they can be mapped. It really depends on that, what would happen on the cloud. It's very, very flexible. But what is being done to date and what we measured is actually a true contact force between overhead line and pantograph. Why is it important? It's important because it tells you how efficient the current collection is on one end. But on the other end, if those forces are exceeding certain limits of 250 or 300 Newton, then you know that something is wrong. The infrastructure will wear much faster, and potentially you can have incident to pantograph. On the other hand, low contact forces will bring sparking effect, which is not good either. So this is the reason why contact force is important. In addition to that, we measure the stagger, which is how the wire sweeps across while the train is moving, and both vertical and longitudinal accelerations on the pantograph head for inertial forces. And this is all linked again to the GPS and video footage. And you can see just at the bottom left one of the way to present it, which I'll show you video shortly. And in order to put this product anywhere in the market or do any pilot, I always believe that and make a parallel that this is similar to health products. If you don't test it in the field, it doesn't show its value. So we did a number of tests in the UK, and particularly tests related to delivering those TSI reports, delivering reports to regulatory bodies. But in addition to that, we did tests where we helped Network Rail to find out where the errors or potential dangerous spots on the network are by linking contact forces with GPS. When we speak about field trials, there are two sets of trials that have been completed. The first set of trials was completed on a slow speed train up to 60 miles per hour. And this train belongs to Network Rail, and they use it to install the infrastructure. So what we did, we mounted a pantograph on this train and we did measurements. And this has been proven to be useful and satisfactory, would allow us to move to the big boys. And this is a class 90 locomotive, which can run up to 110 miles per hour. And we are particularly proud of this work because it resulted in faster journeys between Bristol and Cardiff Central as a result of delivering in-time reports on contact forces and behavior of overhead line. In addition to that, crossovers are one of the critical spots on the network, and we did examination of a number of them where useful feedback is given to the Network Rail and the engineers so maintenance teams could fix those problems. I will now just show you two types or two ways how we presented the data so far. One way is obviously having a video footage integrated with GPS and both sets of contact force and the stagger coming together. And then you can see this is a situation in one of the stations in the UK. When contact force is established, it's about 100 Newton. And the red line shows you where the contact is. I'll just move it fast forwarded so you can see in a more dynamic environment what it looks like. This again, it was a requirement from infrastructure manager to see it in such way because they wanted to see visual feedback at the same time with the data. Another way obviously is to use interactive and cloud-based dashboards where you can monitor degradation and what happens over time. So you can see here contact force trace for this particular journey, and you can see speed of the train. On the left, you can see the events in this table, but when you hover over any of the events, it tells you the date of the event, longitude, latitude, forces, and speed of the train at that particular time. This allows us to see how the infrastructure degrades over time and what they need to do. Okay. So obviously it was a research project. We did it together with pantograph manufacturer and pantograph leader in the UK. And I would say the technology readiness levels wise, we are currently at TRL 7, but we are pushing towards TRL 9, and that's the goal of my recent award, which is Enterprise Fellowship, where I am due to establish a company, a commercial entity to work on this product. In addition to that, we developed a very important piece of equipment, piece of hardware, which is optical-based accelerometers to measure the both longitudinal and vertical accelerations on the head. And we also develop them in such a way that we can put as many as we want pretty much without affecting any performance. And on top of that, we recently developed a system that can log data and do data analysis by itself pretty much. It's fully automated and doesn't require us to be present at the commissioning or test train. That's why I'm emphasizing on passenger services. When it comes to accelerometers, I just want to show you briefly what it looks like. And this is the device itself, which is made by us and manufactured by external company, but we put it together. So the components come to us and we assemble it. This accelerometer itself does follow the standard, which is EN 50317, and is compliant with the system. In addition to that, I just want to mention one more thing which we are working on at the moment, and it's very, very important and could come handy to train operating companies, is to see the status of the carbon strips and when they should replace it. In order to avoid a scheduled or very costly maintenance, the system could tell them, now is the time, take it off, put new carbons on, because these things wear pretty quickly if the infrastructure isn't good, especially. And this is just my last slide on what's on horizon, but there's more and more will be developed over the number of years as this spin-out is being established at City University. And again, to repeat, we are working together with Pantograph manufacturer in the UK. Thank you.
Thank you, Mio. That was very, very interesting. We have one question right out of the box. How does winter weather such as snow, sleet, and freezing rain impact this?
This is a brilliant question, and I can actually answer it because I experienced it myself. So the system itself has been on the train since 2018. So it's almost 2 full years, and literally went through all weather. And I remember very well last year, April, we had snow in the UK. November, we had heavy rains, but July was again 32, 33. And we didn't have any problems, and the system did survive. So when I say moving from TRL7 to TRL9, it is not really about protecting the system, but more making it easier to replace it, so the new Pantograph can come easily on. So
what is the TRL7?
Oh, sorry for not explaining that. So TRL7 is like a European Commission standard of technology readiness levels, and TRL7 means the technology has been tested and evaluated in a real operational environment.
Okay, and then 9?
And TRL9 would be a refined solution of TRL7 based on the feedback from industry, which we are doing now.
Okay, that makes sense. Are there any more questions? If you have a question, please put it in the question and answer box down at the bottom.
Okay, I see there is one question. For the USA, do we have the resource to update train infrastructure? Are we populated enough here in the USA?
So I did answer that one in writing. And yes, we absolutely do have enough population, and we certainly have the resources if we choose to spend them that way, which is part of our agenda, is persuading the government to spend our resources slightly differently. But then we do have another question from Clyde. Does the pantograph behave differently when the locomotive is in regenerative braking mode, feeding power back into the line?
Sorry, can you just repeat it? What is the? Okay, I see there's 2 questions in the chat.
Yes.
Okay, shall I go one by one now, or?
Yes.
Okay, what's the commercial timeline for this product? Will it be remotely monitored, owned by a TA? Do you mean TA by? Can you just clarify that? I can give you an answer on the commercial timeline. So we are currently establishing a commercial entity. Okay, transit delivery. Thank you. So we are currently establishing a spin-out company here at City University and working together with a Pantograph manufacturer. So we are looking for for a pilot project, or a paid field trial project, which we are pretty much would be ready by the end of this year. So in that sense, there is no concerns. Scaling up the project, where you can tell me we need 20, 30 carbons a week, that will take some time for us to develop the scaling strategy, and we are working on that at the moment as well. Will it be a monthly fee or owned by the transfer? This is again a very good question. It comes down to two different target segments. Infrastructure managers in Europe and the UK, they prefer to own the system themselves, and they can do that. So there's no issues with that. While train operating companies are more focused on a model subscription or monthly fee, which I believe is the right model, which needs to be verified. And if you do have experience with a train operating company or infrastructure manager, I'll be more than happy to have that conversation. Does the energy source for the electricity matter? Fossil fuel? No, it doesn't really matter. It's all about mechanical. It's all about mechanical contact with between pantograph and overhead line, in my opinion.
And then there's, in the question, Catherine is asking, how does the speed affect the usefulness of the information?
It does. There's a really interesting diagram between speed and contact force, which is part of TSI, and TSI means technical specification for interoperability. In TSI compliance, there's a graph showing that how the force changes with the speed. And obviously you need to use different measures. So if your operating speed line is more than 240 kilometers per hour, you'll need to use different statistics to actually sign off that infrastructure. There is a dependence, but it doesn't affect our measurement system at all. And in fact, we are getting the data at much faster frequency than it's really needed. We could run it at 200 hertz, and we're currently running it at 5 kilohertz. So we have a really high resolution data.
Okay. And does the pantograph behave differently when the locomotive is in regenerative braking mode?
I won't be able to answer that one. I'm afraid I don't need somebody who has a bit more experience in that sense.
Okay. And then could you explain how the fiber optics work? Those slides went by too quickly. How do we understand the colorful diagram slides? Oh,
I'm sorry if I was too quick. So how the fiber optic works. So the fiber optic sensor, you pretty much launch the light inside the fiber. And then this particular sensor is called fiber break grating. So what it does is it's a mirror inside the optical fiber. And then when a broadband light comes to that mirror, it reflects a particular wavelength, which is predefined. And then that wavelength will shift with changes such as forces, temperatures, pressures, whatever you need. And what you measure that change. And that change tells me, okay, there is 100 Newton between the pantograph and the overhead line. The colorful slide, I'm pretty sure you're referring to the same one on the principle of the optical fiber. If that's correct, I just put the broadband light, which covers all the colors pretty much. That's why it is colorful.
Excellent. Will it also measure voltage and height of the contact wire?
So it doesn't measure the voltage. When you do TSI compliance, you need to either measure current collection or contact force, one or the other. There's no need to measure the both. So we focused our strength on the contact force measurement.
Okay.
Okay, so stagger, up force, and impact measurement. Will it also measure voltage? Height of the contact wire is something we are going to test in 2 weeks' time in the field. So I will tell you how successful we are with that.
Okay. There's a smiley face. Good. Any more questions or comments? While we're here, I guess. Oh, okay. So Bill Porter is asking if Amtrak uses something similar on the Northeast Corridor.
I wouldn't be aware of that. I know there are systems out there, systems which are mainly based on conventional strain gauges. They do come handy on the tests and commissioning trains, which I'm not saying they can't do, they can do. It's absolutely correct. I think it's a bit more of a challenge on the passenger trains, because there was a situation last year when we did testing as a part of Great Western, which is a big project in the UK, and our technology was tested against gold standard, which is conventional sensors. And what happened, every time the pantograph reached neutral section, when voltage dropped from 25 kV to 0 and back, the system, which is conventional sensors based, even though it was isolated perfectly, it stopped working. So I'm not saying, I mean, it obviously gave me more confidence in our technology, but it is a real advantage, because you can imagine you have optical fiber and you have electrical sensor. There's interference, there's different effects. On optical fiber is absolutely free of that. There's no issues, there's no challenges around it. That's why it is more convenient. On the other hand, what else is good about optical fiber? It's a very lightweight. It's adds no mass to the head, which means it doesn't affect your aerodynamic performances, which is important.
And Fred Bonert is asking, can this system be applied to trams, light rail, streetcars, etc.?
Yes, it could. There's no issues with that. I know that the trams, if I am correct, is 1500 DC, and it would be no difference. I know there's more current there, but the system itself is flexible in that sense.
And then Steve is asking, at the phase breaks, does it need a unique power supply?
It uses the common power supply that's already on the train. So it's a very wide range of DC and AC power supply, but it does require to be powered from somewhere, yes.
So I think the answer to that is, like, if you lose power, there's still battery powers on the train that run everything during the time that everything's going. Does that handle it, Steve? Okay. Yes. That doesn't mean anything to me, does it? Oh, okay. If you can connect it to the power of the train, I guess, right? Okay.
This is a very good point, and this is something that we are now discussing with the train operating companies. And power is there. It's up to them now to decide whether they want to put it and use it. But I really believe that there's a bigger picture. The value that this system can bring to them will work down that road. But that it is a challenge. I agree. Good point.
Okay. And then if there's no more questions related specifically to this, I'll open up the floor to any questions about the Alliance or the high-speed rail in general. And Adrian did have a question. How is the contact point measured with fiber optics?
It's measured by strain measurement. So you measure, these optical sensors are pretty much the optical strain gauges. So they measure the strain, and then strain is converted to contact force.
Okay. And then could you expand on the energy saving possibilities of this system?
So when you look at the energy consumption that train operating companies, so that they're paying a massive electricity bills. I know that average is about $500 million per year. And the way that we could help them, we need more data now to get more confidence about the models that we have in mind. But the other way to do that is through what is called closed loop control system. In this closed loop control, what you do, you adjust the contact force as as the train is moving, and then you optimize the efficiency of the current collection.
Okay. And then did you get government funding to design this?
Yes, we did. We ran through two Innovate UK projects so far, and the most recent project that we got is funding. We got is Enterprise Fellowship from Royal Academy of Engineering, which means that they went through our proposal and they allow us to establish a commercial entity. They saw the value that can bring to the market.
Okay.
No strain on force. The actual contact point is it's based on the forces. So you only need 2 points of the contact force to know where the wire is.
Okay. And I want to clarify, with the government funding, that's British funding.
Yes,
right?
yes, it's called Innovate UK.
Okay.
I don't know if there is any schemes between US and the UK joint undertaking or something that would be worth exploring as well. I'll be keen to look into it.
And then how long have you been testing this?
It's been in the field since 2018, so
Okay.
about 2 years nearly.
Okay.
It's run on 2 different trains. I guess it's worth mentioning: 60 miles per hour and 110 miles per hour for 2 different reasons as well.
Okay. Great. Anything else? I'm not sure, Cheryl, what you mean by that comment about Trump wanting to update the structures. Okay, so, and then any questions on the association or high-speed rail in general? No? Excellent. One last thing before we go, and let's see if I can I take over the screen share?
Yeah, I stopped the sharing, so it should be.
Okay, so we should be seeing a thing that says Summer Fundraiser. Is that correct, Mio?
Yes.
So we, over the years, have commissioned artwork. This is actual large oil and watercolor paintings that turned into posters and such. And if you know of folks that would love to have one of these, like this one is my favorite, hanging on their wall, please direct them to hsrail.org/summerfundraiser. You can also get that through the blog. And on the webinars, up to 500 people can join at a time with the system that we have. So Mio, thank you very much for a very, very interesting program. Really appreciate this. Do you want to give out your contact info if people want to follow up with you on anything?
Thank you very much for having me here, Rick, and thank you everyone for joining. I'm so glad I got a chance to present today to all of you. What I'll do, I'm just typing my email address here in the chat, and if you have any further questions or clarifications, or you would like to work together on a trial project or to try to test technology, please do get in touch. I'll be more than happy to talk details.